Hi, boys and girls. Today we're going to continue on with volume. As you can see in today's learning goal, it says I can solve math problems using my understanding of volume. So today's problems that I'm going to be giving you will be solely word problems. Not only will we be working on volume word problems, but I'm also going to introduce you to another formula that you can use for volume. Now, in the past, we've talked about, and I'm going to mark it on here, that volume is equal to length times width times height. We've talked about that on numerous occasions for the past 3 weeks, where we looked at volume questions and it gave us the length, it gave us the width, and it gave us the height. And then all we had to do was multiply the length times the width times the height. Now, not every time are you going to be given all 3 dimensions. There are certain times where you're going to only be given one of the dimensions and the length and the width will be combined. Now remember, whenever you're combining length and width, that's often area. So remember, in the past we talked about area is length times width, right? When we're looking at length times width, we're usually talking about area. We're usually talking about a 2-dimensional shape. What makes a shape 3-dimensional is the fact that you have the height. That's what's the difference between area and a volume. Area is a 2-dimensional shape because you only have length and width. Volume, you have a 3-dimensional shape. You have length, width, and the height. The height is what makes a 3-dimensional shape pop out. Now, if you're given the area of a shape, you can also use that area to find the volume just by multiplying it by the height. So today, that is what we're going to be going over, finding the area of a shape and using that area to calculate the volume of a 3-dimensional shape. So here I have today's problem. It says Handy's hardware store ships washing machines to their customers in cube-shaped box. So I'm going to highlight that because we're talking about cube-shaped box. Remember, cube-shaped boxes, those are important because that tells me it's a 3-dimensional shape. Each box has a volume of 1 cubic meter. The boxes are placed on a trailer that is shaped like a rectangular prism. So again, a rectangular prisms, when we're talking about rectangular prisms, we're talking about 3-dimensional shapes. The trailer is 2 meters tall. The floor of the trailer can be completely covered by a layer of 15 boxes. What is the volume of the trailer? So there are a few important things that are mentioned in this problem. So one thing is that the trailer boxes are placed in a shape like a rectangular prism. So we're talking about a 3-dimensional shape. It also mentioned the trailer is 2 meters tall. So we want to point out that when we're talking about 2 meters tall, and I'm just going to circle that, and I'm going to draw a line. Whenever we're talking about something being tall, we're talking about the height of the shape. So I'm just going to mark that down. So whenever we're talking about how tall something is, we're talking about the height of the shape. It continues on by saying the floor of the shape trailer can be completely covered by a layer of 15 boxes. So if you look at this picture I have here, this is the floor of the trailer right here. Let's move this up. This is the floor of the trailer that I'm showing you in the picture. And it says the floor of the trailer can be completely covered with 15 boxes. So as you can see, the floor of this trailer is 15 boxes. If you count, let's just count it so that we can make sure it's 15 boxes. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So you can see that the bottom layer, which is the floor of the trailer, is 15 boxes. So that's the base, right? If I think about back to area, what area is, and I'm just going to circle that. Remember, area is length times width. So my area here for this particular shape is a 5 by 3, right? Which gives me 15. So I know the area, the layer of boxes is 15, right? And I'm going to erase that because that doesn't necessarily mean it's a 5 by 3 box. But in this particular picture, you can see that the layer, the first layer of the boxes that are on the floor are 15 boxes on the bottom layer. Now, it says also in the problem the trailer is 2 meters tall. So if you look at the picture here, the picture doesn't show the height of the trailer. That's important to notice. It only tells us the first layer. So I have to make sure I add a little bit of height onto my trailer. And I'm just going to mark it. So this is my base of the trailer, right? And then this is my height, right? And it says my height is 2 meters tall. And I'm just going to label that by labeling it 2 meters. All right. Now, the new volume that you would use, the new formula that you would use to solve this, since you know the base with the bottom portion, the formula for today that you can also use to find volume is equal to base times height. Okay? Now, what is the base? The base is the bottom portion. The floor, whether it's the floor or the bottom of the box, that's considered the base. So it tells us here that the base, the layer, is 15 boxes. So we're just going to circle that. I'll use a different color. And I'm going to label that so that you can see that this is the base of the box. So that's the base of the box. So now I can use my formula, base times height, to figure out the volume. So volume is equal to the base is 15 times, and again, remember the height is how tall something is. So 15 times 2, right? So if you look at this, the base is a combination of the length and the width. So the base, again, is covered by a layer of 15 boxes, so 15 times 2. And then my volume is equal to 30 because 15 times 2 is 30. And I can say the volume of the trailer is 30. We'll move it over here. The volume of the trailer is 30 cubic meters. All right, so just to refresh our memory, again, the new formula that we're using is base times height. Now, why can't we use volume is equal to length times width times height? Now, if you think about this problem, did this problem tell us the length? No, it didn't. Did this problem tell us the width? No, it didn't. It only told us the height, and it told us the base area, the first layer of the prism. So whenever you're only given the first layer and the height, you use base times height for volume. All right, so we're going to try this out with another problem here. It says Millennium is moving moving company's smallest packing boxes are cubes with a volume of 1 cubic foot. The trucks in their fleet are shaped like rectangular prisms. So let's just highlight that we're looking at rectangular prism. So whenever we're talking about rectangular prism, we're talking about volume. And it mentioned that the cubes has a volume of 1 cubic foot. Okay. The problem continues on by saying the movers could cover the floor of the truck entirely with a layer of 84 small cubic boxes. So I'm just going to highlight that. If the height of the truck is 6 feet, how many small boxes would fit the entire truck? So again, when we talk about volume, we're talking about the amount of cubic units it would take to fit a 3-dimensional shape. So we have to figure out how many small boxes will fit inside of an entire truck. Now, again, it tells us the layer is 84 small boxes can fit the floor of the truck. And then it tells us the height of the truck is 6 feet. Now, what formula could we use to help us find the volume of the entire truck? If you mentioned volume is equal to base times height, you're correct. Remember, in this particular case, we can't really use volume is equal to length times width times height because it doesn't tell us the length, it doesn't tell us the width, it only gives us the base of the floor of the truck and the height. And it tells us, if I drew a quick picture, it tells us the base of the truck, which is this bottom layer here. And I'm just going to mark this bottom layer here. I'll put a circle. The bottom layer of the truck, which I'm going to here in this circle, is 84 cubic feet. Now the height it mentions is 6 feet. So I'm going to go ahead and put in my 6 feet. So now I can calculate the volume. So I'm going to go ahead, volume is equal to base times height. The base is 84 cubic feet times the height, which is 6 feet. And then I could do my calculations for 84 times 6. I'll do that along the side here, just for anyone who's still struggling with multiplying. I could do 84 times 6, show all my mathematical thinking. So I know 4 times 6 is 24. Write my 4 and regroup my 2. 6 times 8 is equal to 48, plus 2 is equal to 50. So I can see here, this is the volume, or how many cubes or how many boxes can fit into the entire truck. And I'm just going to label it. So 504 boxes can fit into the trucks. And I'm going to go ahead and state my answer in a complete sentence. The truck can hold 504 small boxes. That is my answer. All right. So as an exit ticket, so this is our work for today. So as an exit ticket, I want you to complete this problem that says a retail store received a shipment of globes. The globes are packed in cube-shaped boxes that each have a volume of 1 cubic foot. The truck they were shipped on is shaped like a rectangular prism and has a height of 10 feet. If the floor of the truck was completely covered with a layer of boxes, 80 boxes, what is the truck's volume? Okay, go ahead and complete today's exit ticket. And then after this lesson, go ahead and move on to your assignment for today. Have a good day.